without any more ado, I will hand over now to Michael Cohen of Rapid7 to talk about Velociraptor, I should say, and some digging deeper. Thank you, Michael.
Thanks, Brad. So thanks for having me here remotely. Today, I would like to talk to you about Velociraptor and just kind of introduce you to the tool. And a lot of the material that I'm going to cover, I've covered sort of before, but I've got some new material as well. So it's quite interesting to see how the tool evolves, over time. So for those who haven't heard about Velociraptor yet, it will be a good introduction, and it'll be kind of a hands-on exercise. A lot of hands-on exercises that I encourage you to do, on your own machine or afterwards. We're gonna, reviewing the video or whatever. Let's have a look at now. There's no real way that we can cover everything in Velociraptor. There's just so much content. So today is going to be like a little taste to see what's possible and how Velociraptor is really changing the field of digital forensics and incident response. So if you want to follow along, you should have your own VM. We're going to be working with Windows today, so you should have a Windows VM with administrator level access, and we're going to simulate a lot of attacks that typically people see in the wild, and how Velociraptor can be used to detect these kind of attacks. So there are some tools that we will download and so on. So it's probably best to work on a Windows VM. None of them are actually malicious, but if you have a corporate type thing, that security tools, they might interfere with what we're about to do here. So here's a list of some of the tools that we're going to be using today, and we'll be using other ones. So we can we'll get into that later. So today's workshop is 4 hours, and we're going to do maybe a couple of hours. We'll do like a 5-minute break sort of in between the first 2 hours, because it's just too long to talk for like 2 hours straight. Then we'll have a lunch, and then we'll do the second session. And we'll see how far we can get through all the exercises. There's quite a lot of exercises, so we'll see how far we can get through. All right, so let's dive straight in. So what is Velociraptor? So if you haven't heard, Velociraptor is a free and open source DFIR, digital forensic and incident response tool. And the really unique thing about Velociraptor is that it has this query language, which we're going to look into a little bit later. But that gives us the ability to customize our detections and customize our analysis like on the fly. Oh, by the way, so this is because this is like a small group. If you have any questions at any time, just pop in, right? Like don't wait, interrupt me at any time, and you can use the Zoom chat to write questions in. I'll be watching that as well. So don't be shy. So VQL is used to drive all the forensic capabilities. So basically, like a lot of other tools, they have forensic capabilities or analysis capabilities, but they don't have a way of putting those things together. So they end up with so this is where it's really unique for Velociraptor. We have all of these analysis tools, and when we put them together in a flexible way using this VQL, and that allows us to create new kinds of detections, new kind of analysis on the fly. And that's how we do it. We write these custom, what we call artifacts, which are just ways of extracting specific informations or specific questions from the endpoint using the VQL, and that allows us to adapt really quickly to new kinds of threats. So that's really kind of the strength of VQL. And then we can use that, and the fact that Velociraptor can be deployed widely on a large number of endpoints to hunt. We're going to see that over thousands of endpoints. So we can do very efficiently, we can query a large number of endpoints, but even then, the forensic capabilities of Velociraptor is, those capabilities are running on the endpoint. So they're actually, we're still doing those very same forensic analysis that we normally do, but we're just doing that at scale. So that's kind of the interesting thing about Velociraptor. So this is kind of what it looks like in a high level kind of overview way. We have our server, Velociraptor server, and these are all our assets. So they're just kind of like laptops, servers, these kind of things. They have an agent installed on that. And we have a persistent communication to the server. So that means that it's persistent. It's not polling like other tools. Because it's persistent, we can task it immediately and it will do it. So it's very quick. It's very quick to interact with it. Then we have an admin UI, which is how we administer Velociraptor and run hunts and queries and these kind of things. We'll use that today. So the server deployment is usually in the cloud. We usually put it up on a cloud server, but it can run also, on-prem if you want to. And it's basically a single server. Usually, single server is more than adequate for most networks, and we can also use multi-server architecture for very large networks. So we support Linux, Windows, and Mac, and FreeBSD, and potentially others. For example, like we can run on, Raspberry Pis and things like that as well. So, but we don't do like mobile type, Android type, or iOS type things yet. And the thing about Velociraptor is it's really fast, and you'll see that today. It's actually really, really quick. And the reason why is because the server doesn't really do all that much. So because we have these VQL, all of our VQL is running on the endpoint. So if we're doing a query like search the MFT for whatever, that searching and analysis and MFT parsing and all this thing, it all happens here on the asset. So what we're getting back from that is just the results, the hits, the things that we're interested in. So the server doesn't really do a lot of analysis. It just takes the data and just writes it. So it's very quick. And that allows it to scale. So using that, it can scale to very large numbers. And of course, we can control how much memory and CPU we use on the client, and there's various other methods. So it's all about stability. It's all about working at scale and making sure it's it's usable at large scale. So there's a lot of ways at which we can control how we operate at scale. So typically, what we recommend is anything up to maybe 10, 20, 15,000 or 20,000 endpoints. One server is more than enough. It's fine. Usually put it in the cloud just because it's easier, and also because you have faster bandwidth typically. But you can also do it on-prem, as I mentioned before. When you go up to like large levels of clients, large number of clients, then SSL loading becomes a problem. So if you want to go a little bit higher than that, you can do things like TLS offloading and other things like that. Typically, like this kind of VM is huge towards the top of the range, and usually we use like much smaller VMs for 5,000 type endpoints. So it's not too bad, right? So it's actually quite a bit more efficient than many of the other tools out there. We usually run on a Debian server just because it's easier, and also I think that Linux file systems can deliver better throughput than the Windows ones. So I think that's the recommended setting. And if you want to go up to 150,000 endpoints, we can see like multi-front end setup. So we are not going to talk about that too much today, but it's documented on the website. By the way, all of this is, if you just go to Velociraptor DFIR, search for that on Google, and you'll see our documentation pages right here. And over here, you'll see all of the deployment guides and installation and all this stuff. So there's lots of information here about how to actually deploy it and so on. So I'll point out different parts of the website as we go along, so we can see what's relevant as well. Okay, so what we're going to do in the first part of the workshop is play around with it, install it, and have a play and see a little bit about the tool, what can it do, and that kind of thing. So for this workshop, we don't want to have a very complicated deployment. So we're just going to use this machine here and run Velociraptor locally on our machine. So the first thing we got to do is we got to download Velociraptor, right? So we're gonna go to the website, go to GitHub, and grab the tool. So it's open source, of course, and you go to the latest release, right? Which will change as time goes on, and then over here we will see all the assets. These are the different releases that we have. These are binaries that we release for different operating systems and so on. So because we are on Windows today, I'm going to use the Windows one, which is this one. Okay, so we can download it. There's also SIG files that you can use to verify with GPG and so on. And what it is, it's not really an installer, it's just an executable. That's all it is. And the executable can do everything that Velociraptor does. So there is really no other files. There's just an executable. Everything is included inside of that executable. And that executable can act as a server, can act as a client, can be used for administration and various other things. So it really is just a VQL engine that runs VQL queries. So you can just use it for local collections and so on. So all you do is you just download it and then show in folder. Okay, and there it is, right? So we're gonna you can look at it. It should be signed, digital signature, verified, and so on. So you can see that it's verified. Now what we're going to do is start up an administrative shell. So let's start a new one. CMD, and make sure that you run it as administrator, so that we need that to access the low-level NTFS drives and so on, right? And let's go to our user. This is our test user. And over here, we should see our file here. So if I just run it by itself with no command line arguments, then it's just going to print a little bit of help to tell me about what can you do with this tool, right? So there's a whole bunch of commands that you can run, right? And they have options and so on. And you can use -- help with the different commands to see what options are available, sort of thing, right? For this for us, what we're going to do is we're going to run this command called GUI, and all that does is it will start up a new server with a new client all set up. So it's just like I guess it's like a demo kind of. It just basically starts its own deployment, and we don't really have to configure anything. It just creates a local deployment. So let's see how that works. So we're just going to run it with the GUI command. Let me just make that a bit bigger, just in case it's hard to see. Font. Yeah, maybe this. Yeah, that's better. Okay, so we're just going to run it with not dash, just GUI, right? So just the GUI command, like it is, right? And so we'll see that when it starts up. Let me just scroll up to show you. Start with Chrome. Okay, let me just scroll up to show what happens. So it starts up for the first time. It tells you the version that it's running and so on. And then what it's going to do is it's going to build a new configuration, and it uses the temp directory by default, but you can change that. For here, because this is like a demo mode, it builds its own configuration. It's just ready to go, right? So you don't really have to do anything. But if you want to deploy it for real, then you can check out the deployment guide that I pointed to here. That tells you, how to deploy it, properly. But there's like a configuration wizard that you go through and answer questions, that sort of thing. But then you can see it basically starts up and it will create a client and a server. So client, again, is what we call the Velociraptor that's running on the server, on the endpoints. So if we look at our installation directory, that is called the client, that is called the server. So it's kind of simple. Okay, so when we start it up, it will open up a browser window, which will be the administrative interface. And by default, it uses a self-signed SSL certificate for that. So because it's only local, right? So it runs locally, and you'll see that it listens on local host 127.0.0.1. So it's not open to the world, it's just local. And it's got a hard-coded admin password so that you can just use it locally. So it's like a demo type interface. And so it's just a quick way of bringing up the interface so we can see the tool and we can go through. And it's exactly the same as what you would get when you deploy it for real. Of course, it only works locally, but when you deploy it for real, it will work, widely. But then we can use that to, play around with the UI and learn about the tool. So that's all you really have to do. That's really not much to it. So let me just go and show you so that would be the admin password. If your browser didn't offer it, then you can use that to log in. And you can change the data store. So at the moment, let me just zoom in on that. So at the moment, by default, it uses the temp directory. But the problem with the temp directory is that files get deleted all the time. So if you want to do it more permanent basis, you can tell it to use this as the data store. So by the way, I did not mention before, Velociraptor does not use a database for the backend, or it doesn't really use any other dependencies. It just uses flat files in just a directory. So there's really nothing complicated about installing it, because it's just going to use a directory and put all its files in a directory. So you can, and that's the data store directory here. So you can change that to any other directory, and it would be as though Velociraptor started fresh on a clean machine. So you don't really need to install anything. It just works within that data store. It only writes here. So you can have multiple Velociraptors servers pointing at different directories, and they all just kind of coexist happily, right? So there's no other effect on the system. So that's kind of so if you're going to use that more permanently, then you should probably set a data store. So just so that files don't get deleted, by the operating system because they're going to temp. All right, and then and I've mentioned that we're going to use HTTPS, and it's going to be on localhost, right? So that's kind of what we are seeing here. All right, so let's take a look at the GUI tour and see what see what we can see in the GUI. So by the way, this is our website, as I mentioned before, and this presentation you can find here under presentations, and all the other presentations as well. So if you want to follow along with the slides, they're just here, and you can click this to open them up in the full screen. All right, so let's have a look. So I'm just going to go off and ad-lib it a bit, because this is just kind of like a tour of the UI. And so this is the welcome screen, what we call the welcome screen. So it's just kind of like the first screen you see. Now over here on the top right, this is the user label, the user panel, I guess. And you can log out and things, but if you click on the name, then you've got the user settings, and you can control various things about the interface from there. And probably you'll notice that the first thing that we're going to see is this is the default theme, I guess, and it's not. It's kind of all right, but it's not. It's a bit old looking because it's using like an older Bootstrap type theme, so it's kind of a little bit older. But if you want to change it to something with a bit more color, then you can just choose a different theme. I mean, it's a small thing, but it's kind of cool. So we have a different themes here. So, I like this one. This is like a bit of a, more of a flat theme. We have like a pink one. think this one is also my favorite. It's a good one. So, you know, there's just different colors. You know, it's kind of nice having different colors. And also you can have different languages as well. So you can change it from English to, you know, German, Spanish, whatever. My download link, there's a question here. My download link at DFRWS APAC site provides no way to download. So the download link is pointing to the GitHub, to the GitHub, right? So the GitHub, you have to go to, so this is the GitHub site, right? And then you have to go to releases here. And this is where you get your binary from the releases part. Cool. All right. Yeah. So we've got different themes. We've got different languages. You know, it's kind of nice. This is Japanese. You know, Francais. You know. Anyway, we'll leave it as English, and that's kind of nice. I'm going to point out some of the other ones a little bit later on, but that's. Let's go back to. Oh, there's some dark themes which are, you know, some people like dark ones. This is a very dark one. This one's less dark. Anyway, I like this one. We'll do this one. Yeah. So the first thing that we can see. So let's go back to the welcome screen. You can click on the Velociraptor to go to the welcome screen, and it has a number of links here. You know, that you can read if you really don't know where to go next. But usually, the first thing that you do is you want to search for clients because you want to interact with the clients, right? On the endpoints. So this is our search screen here, and this is where we get to search for clients, right? So if you don't type anything, so you just click this, or it's the same. You can just pull down and show all. That will show all the clients. Now, at the moment, there's only one because we only have one client connected, but you might have, you know, 10,000 clients here or whatever, right? So you might have a lot. So this is the search screen for all the clients. Now you can see that each client has a client ID. It starts with C, and that is known as the client ID. So that is how Velociraptor internally identifies clients, not by host name, but the ID can't change, right? So it doesn't change for each machine. We have the host name as well, but we don't use that to identify it. So typically, usually in an investigation, you use host name, so you can search for it. So you can, if you search for the host name, see, we can search for it and then just find the client that way. But internally, it's always using client ID. So have to remember that, you know, OS version and so on. And then over here, we have something called labels. And a label is a way of grouping clients together. So if you have a lot of clients, then you can group them by label. So you put a label on a client, you can set or remove the label. And I'll show you here. This is how we set the label. So we click on that. Oh, first we highlight it, then we click on that. And then we can select a label. So we can select an existing one, but I haven't created one yet. Or we make a new label. So for example, if this one, we're going to call it a dev machine, for example, and that will be the new label. So when we add it, so it will add the label to that machine. Now, labeling is really useful later on. We're going to see with regards to hunting. We can see how we can target specific operations to groups of machines. So when we have like in a real deployment, you would have like sales, you'll have, you know, legal, you'll have accountants, different departments and so on. And so you can target for based on that. Or if you're doing an incident response, then you can add labels to machines that you've determined are compromised, and you need to look at them in more detail so that you could prioritize operating on certain machines and so on. So this is where labels are come in, very important. So we've learned how to search for clients. You can delete a client as well, but that's obvious. If you delete a client, then it would just, you know, and it's still live, it will just come back because the client itself connects. And Velociraptor is a zero registration system, so you don't need to kind of pre-deploy or pre-provision like the clients in advance. As long as the client is running, it will connect to the server and just automatically register. So if you delete it from the server and it's still running, then it will just register as a new client again, right? Immediately. So, it's good to clean up occasionally. I mean, this is useful for, clients that are kind of dead, like they've been uninstalled or rebuilt or whatever. So they're not coming back. So if I click on that client ID, then I can see this is the record, the client overview. This is the overview of, the client. So just kind of metadata that we keep about the clients, right? So as I mentioned before, the client ID, the agent version is when it was built. So the build time of the agent, then the name, and then when we first saw it. If you highlight it, then it tells you how long ago, 11 minutes ago, right? And when we last saw it. So we've got 4 seconds ago, 0 seconds. So as it comes in, it updates that. And then the IP address. This is because this is only local host, but normally it would go out to different ones. And then we have the list of labels. If you click on that, that just removes the label from the machine, right? So you can label, and you can add labels from here as well. It's the same thing. And then we have a bit of information about this. And here is where we can put additional metadata about the client. So for example, we can assign, this is like a free-form type thing. So a lot of people use it as a process. So for example, like escalate, Mike, Mike. And then that can be anything, right? And then you can use internal processes to say, hey, these are machines that are escalated for you and these kind of things. So you can just collect like metadata about the client here. So this is over here, you see this is the left side is the navigation bar, and this is the host information part. And in here, the host information, we've got a number of options. So we're just going to go through it. This is the overview. You can have something called VQL drill down. Now it's called VQL drill down is because we can customize this dashboard using VQL, Velociraptor query language, to show pretty much anything about this client. But by default, we show all this information about this client. So before we just saw the build time, but now we know the version, and we've got the build URL. So our binaries are built on the CI pipeline. So we can see where the binary came from. Basically, this is for, supply chain type provenance. And then we've got MAC addresses, kernel versions, all this information. So this information is like the high level information. Now, over here, we've got the memory and CPU footprints over the last 24 hours. So we always collect telemetry about the client. So we know whether we've used too much memory or too much CPU on the endpoint. So we've got running telemetry, always. And so we can see like over here, we're using 73 megabytes and 2% CPU, over the last, we only just installed it, right? But that's pretty typical for, a fairly idle client, because we haven't done anything yet. And as we do stuff like hunt or whatever, we'll see little spikes and we can manage that. And then down here, we've got some more information about the network and, the computer and various things. Here we've got the users on the machine, that kind of thing. So these are just about the endpoint. So it's kind of useful stuff. Over here, the next one along, we have the possibility to run shell commands on the endpoint. Let me just go back to the slides and see whether I covered all this stuff. So we showed the dashboard. Oh, we haven't shown the dashboard. Sorry, I missed that. So the dashboard is the home screen here. So the home screen is just a dashboard about the server, showing us things about the server status. So over here, we see a graph of the server memory use and the server CPU use. So this is useful, just to see how your server is going. And because, in this configuration, it's the same thing. The server and client are the same, right? Because they're just running internally. So again, we're running at about 70 megabytes memory use, and the CPU use is 1 or 2%. It's quite small, and we only have one front end at the moment, so that's fine. And then we've got one client connected. We will see later on when we connect more clients that this goes up, right? So we can see how many clients are connected. And again, because the clients are always connected, so it tells us the instantaneous, like how many clients are connected right now. And then over here, we can see how much disk space we have left. And this is really important when you're running, in real life, because especially when we collect a lot of forensic artifacts, then we can fill up the disk space pretty quick. So you've got to kind of keep an eye on it and see how much disk space free you've got, and where which drive. Sometimes you can have additional drives, especially on the cloud. You can attach another disk with a lot more storage to the VM and store stuff there. So you can manage this disk space here. These are the Velociraptor users, who's allowed to log into your server, and the version. So again, this is the version of the server. Okay, so we've done that. Yep, so we can see this dashboard and how it works. Okay, so what we're going to do now is we're going to investigate it, interactively investigate a client. So this is like you're responding to an incident and you want to look at one of the endpoints. So the first thing you do is you search for it, which we've seen, right? And then you've got information like last seen IP address and so on. We've seen that. So we've seen the client ID. We can put like arbitrary metadata and so on. And then here, you can run PowerShell commands. So this particular one, get local group member, it's just a PowerShell command to tell me if there's any local administrators installed on this machine, right? Which will be important. Because what would happen normally is a machine is compromised and they add an additional local admin. So we can see that. Okay, so we go over here, we can select to run it with the PowerShell, right? And then it's like, what was it? Get local group member. Local group member dash group administrator. Yeah. All right. So when we do this, when we launch it, it goes off and schedules that on the endpoint. And again, because it's constantly connected, it actually goes and does it immediately. We don't have to wait for it to poll and stuff like that. And then we can see here that we can, sort of show the, this one is just like showing and hiding the output, because, it can get quite busy here if you show the output. So it's normally hidden, and then we can just view it. So we can see, who's the local administrator on this machine. The user test is a local administrator. So you can tell in this case, but it's kind of useful to have, the ability to just jump in and do a, and have a couple of the flexibility of having shell access. But generally we don't really run a lot of shell commands because it's not easy to control. If you do a typo here, maybe there's going to be, damage to the endpoint, or, delete all the files or whatever, right? So we try not to do that too much, and you need to have special permissions to do it. If you can secure the Velociraptor installation with different level access control. So generally that's like an administrative task. All right, so it's flexible. We can run arbitrary things, and we can also run arbitrary VQL on the endpoint if we wanted to, or run through PowerShell or CMD. And if it was a Linux machine, we would use Bash as well. All right, so that's cool. The next thing I wanted to show you, so interrogate is basically just scheduling. It schedules a collection of these things. So it's just refreshes this basic information. The next thing I want to show you is the VFS, or the virtual file system. And the virtual file system is useful to visualize the files, on the endpoint. And a lot of the time we just want to kind of like have a quick browse at a file system in the endpoint. and see various files. So this is not really browsing the file system on the endpoint. It's browsing the cached copy of the file system, on the server, right? So over here, we have, these are called accesses, and it's the way that we access different file systems. So the auto accessor uses file system APIs automatically, but if it can't access the file using the file system API, it falls back to automatically falls back to NTFS parsing for Windows, because the file might be locked or whatever, right? So so usually we recommend to just use the auto one most of the time, right? Because unless you have a special reason, you would only just use that. So we can basically refresh the directories, and then we see all the drives on Windows. That's the first C drive, D drive, and so on. And then you highlight a directory and you click this refresh. That goes out to the client and fetches the directory listing of that directory and then refreshes the UI. So what you're seeing in the UI is like a cache of what the files were on the client at the time. So you can sort of navigate that. It's a pretty straightforward interface. We have like the users, and so you can use that to kind of like go in and and descend each one. So that button just refreshes one directory, but if you press this next one, that refreshes them recursively. So if you go into like the C drive and refresh it recursively, it's going to go and find all the files on the C drive, which could take a while and probably return too much data. But if you go to, like, say, the users directory, it's probably less files, so you can sync, less files, so it's a little bit better. So you see, it's pretty quick. And by doing this, now it would have a more complete, listing of the directories. It's like recursively, search for it. Yeah. So that's that. Oh, and you can also download files. So if you are here, like let's say test desktop.ini, then you see this button, collect from client. You can just fetch that file, right? And when you fetch it, what happens is you'll go and get it, and you'll see a little like floppy disk. That means the server has a copy of that file, so you can look at it, right? Because again, this whole thing is just the server cache of these files, right? So when we're clicking on this interface, normally we don't really go out to the client. We just look at what the server has. Because the client may actually also be offline, right? So we can still look at data that we've collected previously, but without the client being online. All right, so we've done that. So yeah, we've done that. Yeah, we fetched files from the endpoint. So we go through, and when we fetch it, we get so this desktop, this one shows us the NTFS. So we use the auto accessor, which uses the OS APIs. And I said usually you should use the auto because that's most of the time what you'd want. But the one case where you could use the NTFS analysis is when the NTFS parser can give you more information, and that example is in the case of time stomping, when you try and detect time stomping. So if you suspect the file is time stomped, then you can use this NTFS accessor to look at the files with the NTFS parser. And it looks a little bit different. So the top level only shows us the devices. And in here, where was it? Okay, in here, the top one, you see we've got C, D, and E, but C, D, and F, but these are network drives. So they don't really appear in NTFS because they're not NTFS, right? So these are network drives. But these ones, that's the NTFS one. And then we can look at that. And so the view is a little bit different because what we're seeing now are NTFS objects. So suddenly we can see all of these NTFS files. We'll look at that a bit later. But these are all internal NTFS files, which are normally not visible. And then what we can see is next to some of them, we have a little clock icon here. And what that indicates is that the file may have been time-stomped. So time-stomp is when we change the times of a file. And using NTFS analysis, we can tell that because we have multiple timestamps on different attributes in NTFS. So we'll see that later. Time stomping is kind of useful, but it's not that useful, I don't think. I don't tend to use it that much because you know, the good threat actors, they do time stomping properly, so you won't detect it using traditional means anyway. And there's just so many false positives because, as you can see, when you install something from a cab file or whatever, it time stomps anyway because that's how it is. Yes, exactly. So as you can see, it provides the FN times and as well as the SI times, and this is only a summary of what we can get, and we'll see that later. We can see much more detailed NTFS information, but this is just an overview, right? It's just like the level 1, right? so you've got this additional metadata coming in here, but and this one allows you also to, you know, you can browse the registry as well, you know, and do that. But I don't find that's very useful because there's just so much in the registry anyway. But it's useful to maybe get one key out anyway. All right, so this is showing us the highlight here, but it's only a visual indication. It's not that reliable. Maybe it's useful. I don't know. We can take a look. So yeah, we refreshed the directory, recursively refreshed the directory. We saw like how it's synced up for 6,000 files, you know, real quick. Collect from clients, we got the file, we saw that, and then we can do the recursive refresh and so on. Let me just zoom in like this. This is the screenshot. Okay, cool. So this was kind of fun, but you know, it was kind of a pain. If you've ever done a real investigation, you see, if I had to sit here and go, oh, you know, okay, I will need to find this H key, users key, and you know, I'm gonna have to, you know, click on this and see, oh, look, you know, there's a few users, and then call in there. It takes time, and it's very manual, and it's very, a lot of clicky sort of stuff. And when we're doing an incident, we want to work faster and smarter, so we don't really want to do that, right? So this interface here is good for like newcomers because it's very familiar. It looks like, you know, Windows Explorer kind of thing, but it's not a very efficient interface because you have to click a lot, and it's very GUI focused. So what we really want to do is we want to automate a lot of this stuff. So what's happening in here, and I mentioned before very briefly that Velociraptor is really a VQL engine. So it just runs queries, VQL queries. And then I briefly mentioned that the queries are wrapped inside artifacts. Now let's talk more about that. What does that mean? So let's have a look at what happens when I'm clicking around this interface. So if I open this thing on the left side, collected artifacts. So this is showing me all the different artifacts that I've collected, you know, from this endpoint. So this is the endpoint I'm working with right now. So let's have a look. And you can see that it's just a list of artifacts, right? And you can see that it has VFS list directory. And then, you know, we downloaded the file and we listed the directory. And these are all, if you look at the parameters, you see this is where I listed the registry. This is where I listed the C drive with NTFS and so on. This is where I fetched my desktop.ini. So what we are actually doing in the UI is underneath, you know, under the dash, what's happening is Velociraptor is collecting artifacts from the endpoint. So what is this artifact? These are artifacts, right? They have a name, and they essentially encapsulate some VQL queries inside of them. But we don't need to really know about the VQL. They're just like little, I guess, programs, almost VQL programs. If we click on this button here, so this one's telling me these are the different collections, right? They are collections, and they have a flow ID, which is the collection ID. Basically, it's an ID, unique ID that identifies this collection. And, you know, it was created and that sort of thing. So let's have a look at these in the overview here. The artifact name, that shows us the name of the artifact that was collected in this collection, right? If I click on that, then it tells me more about this artifact. So I'll know more detail. What does it do? What does it collect exactly, right? So here's our artifact. We have a little bit of a, you know, explanation. What is it? What does it do? and it's telling us this particular one is used by the GUI to populate the VFS. Okay, so it's an internal one, right? It's just used internally to populate the VFS, but it's still the same, right? It still runs VQL. We have parameters. So parameters are a way that we can change or influence the VQL, how the VQL works. And then we have, the VQL, right? So this is the query language. I'm not going to go very much into the query language right now, but that's the thing that was running on the endpoints. You can look at the request, and this shows us the provenance of what VQL actually, was sent to the endpoint, and then it runs it. All right, so these are called artifacts. So let's have a look at why have an artifact. What's the point of that? Why? So the artifacts are they encapsulate a VQL, query language. But why do we even want a VQL? Why do we want a query language at all? A lot of tools don't have it. But why do we need to care about it? And VQL sort of, grew out of the necessity from earlier tools of having a very flexible IR platform, because the problem was that it's very hard for us to add new kinds of analysis to a widely deployed tool. For example, like with other tools, like with Yara, we were thinking, okay, let's add the possibility to search for files by timestamp. Okay, great. So we added that, compiled it into the client, deployed it widely, and then someone said, "Oh, I wish I could, search for the files by something else, content or size or whatever." And then we had to you can always code that up and write it, features into the client, but rolling out clients and pushing them out is actually really hard in a production environment, right? You have change management and other things, right? So it's not easy to do that. And so what we really needed to do is have a way to flexibly change the criteria by which we're querying for these things, right? Because most of the time, that's 90% of the time, that's really what matters, right? We have a new IOC. We are looking for something that has a particular new thing, a new kind of indicator, right? And so we can just write an artifact for it, putting together these existing modules that do more complex analysis, and then we run it everywhere, and then we turn it around, create a hunt, and off we go. So this is why a VQL, a query language, is really flexible for us. But it's kind of a pain, right? If we had to write a query every time we wanted to use it, it's just a pain, right? Because a lot of people would have to learn, like in OSQL, you have to learn SQL, and then you have to type it in, and then you have a typo, and then it's not right. So what we wanted to do is create something that we can reuse and share. And so this is the idea of putting the query in a YAML file that can be shared with the community and can be easily used, right? So, and you can also customize it, right? So we have this public artifact reference. Let me open that. Okay, and this is all the artifacts that come with Velociraptor. We can search for them here, but you can search for them in the tool as well. But over here, we've got the artifact exchange, which I'll talk about in a minute. But these are all artifacts that we can look at, and you can see that they have it's like a YAML file. It has a name, right? That's the name of the artifact, and the description. But you don't really need to worry about the VQL itself most of the time. You just use it as it is, right? So let me just show you what VQL is. So we talked about why we wanted a query language. So let's talk about what is this query language. So we wanted to have a language that's really easy to use, really simple, and most people get it right away. So you don't need to kind of learn Python or Java or like a programming language. And so it's kind of a compromise, right? It's not a really powerful language. Like you're not going to be able to write like really powerful applications with it. It's not designed for that. It's designed for being able to write very quick, very simple types of queries, but still be flexible enough so that we can do some pretty amazing things. So the idea was to keep the language syntax really simple, so everybody gets it, right? And then put all the functionality inside what's called plugins or code. And so we can write some very sophisticated plugins, Parsing, TFS, or whatever, right? Very sophisticated, but they're essentially like, but the user just calls them and uses VQL to kind of glue them together and get better functionality in a creative way, right? So this is kind of the design choice of VQL. So the idea was, let's find a language that's really easy to use and everybody gets, and probably most people have seen something like that, you know. And so the model for that was SQL, but SQL gets really complicated really fast. So we didn't want to make it too complicated. So we are only using, like, you know, SQL 101. So it's like a very simple thing. And then that's it, right? We don't go into more complicated things in SQL. So we use this kind of sentence structure, like in SQL, select something from something where something. So this is kind of like SQL. So we have three parts in the sentence, in the VQL sentence. The first part is these are column selectors. They're basically, so first of all, it's a query, right? So as all queries, they return rows and columns. So return a table, rows and columns. And you can see that we have the columns. So this basically tells us which columns we're going to return, right? So X, Y, Z, we're going to have three columns, X, Y, Z. Now, and then we have a from, right? And then after the from keyword, then we have the thing we're going to get the data from, right? Which we call our plugin, VQL plugin, right? So a VQL plugin is basically a piece of code that generates data in rows, right? So because it emits lots of rows, right? So there's a plugin. Now, because it's code, it's not like SQL. It's not really a table. It's actually code that runs. So we have to be able to give it arguments. So the syntax here is a little bit different than SQL. We're just adding arguments, so we can provide different arguments for this plugin, because it's not really a static table like in a database, right? But once we give it the plugin runs, it starts to emit rows, right? And then we're going to filter those rows with a filter. So then we have a filter condition after the where clause. So that's basically VQL, right? That's really it. You know, we don't really have any other syntax, and it doesn't go, well, we don't have other syntax that from SQL. It doesn't really, we don't really have joins or anything like that. Like, so as soon as, you know, SQL, you have joining from tables, left join, right join, you know, inner join, outer join. We don't have any of that. It's too complicated. We keep it out. So we're just keeping it very simple here. And that is really all VQL is, very simple. So using this VQL, we can build very, very powerful artifacts. Let's see how that happens. So with Velociraptor, all it is a VQL engine. So by VQL engine, it's just something that evaluates these VQL and returns the rows. And then what we do is we take that VQL query and we put it in a YAML file, put a description on it, and then we put the queries into a part of the YAML called sources. Then we have a parameters so that people can change the way that the query runs, right? And then we can also build on that. So we can encapsulate it and call it from other VQL. So we can build like a hierarchy. So we've seen that. So we've seen that when we click the VFS stuff, we could just collect, you know, list directory, download files, and so on. And because I don't know if I pointed it out as well, but when you look at the collections, because it's just a query, right? So it collects tables. Here is my results. Every query returns a table, right? So it has columns here and rows, right? And so it has number of rows returned. So every query returns rows. That's really all it is. Velociraptor can't return anything else. It always returns tables, columns, and rows, right? So every collection just returns rows. So these are the total number of rows that are returned. And also it can collect bulk data. So for example, when I downloaded the file, it collected bulk data as well. And if I click the uploaded files tab here, then I can see the files that were uploaded, like how many bytes and stuff. But so these are counted as separate, right? So they are like, I mean, 524 bytes, right? So this collection, so a collection can only collect rows and bulk data in the forms of uploads, and and it takes certain amount of time to run, and and that sort of thing. These are like limitations, timeouts, and so on. And then here we can see this is the summary of the results of what this collection gave us. So it collected this artifact, and it gave us one row, 6 bytes in this case, because we are uploading the file. And this one, list directory, collected 6 rows and didn't upload anything. So we've got the options here, right? So this is basically what queries do. Okay, and we can see that in the UI here. So the whole point of like why are we doing this is to be able to simplify digital forensics and incident response, right? So the idea is that we could have a very complicated analysis methodology, but at the end of the day, what we want to do is encapsulate that in a VQL artifact and then have people use it. So we don't have to, everybody doesn't have to remember, oh, where is the normal location for prefetch file? Where are they living? How do I parse prefetch files? How do I do this? There's a lot of domain specific knowledge in DFIR that, is not, or in digital forensic, that, I mean, it's nice to have, but at the end of the day, we really need to get past that and just look at the high level. What am I trying to achieve here, and how to do this? So if we automate a lot of these low level stuff, then we don't need to go back and just know it. We can share that expert knowledge around with other people. We can, and then, people don't have to have years and years of experience to be productive. They can just, get there straight away, click a few buttons, so to speak. Okay, so let me just show you real quickly what an artifact looks like. So we talked about an artifact here, and we saw these artifacts. Now over here, we can see the artifacts separately. So this is what's called the artifact repository, or the artifact library, I guess. It's a library of artifacts that we maintain, so that come with Velociraptor. So they all come here. There's lots and lots and lots of them, right? And if I click any of them, then I get to see a little bit of a view of them. This is just all generated from that YAML file, and we've got the name with the client. So we've seen that view before, but in this is the repository view. I can edit it or add new artifacts. So if I click on this, it will allow me to add a new artifact. And let me just click on that little spanner and just make the font size a bit bigger so you can see. So you can see that when I create a new artifact, it just puts like a template in there to like help me out, so I know what to fill in. And this probably 95% of the time, that's all you need. It doesn't have all the fields that you can fill, but 95% of the time, that's what you'd want, right? So we start off with the name. You got to give it a name, right? It doesn't have to start with custom, but usually the convention is to start with custom to indicate that's a custom artifact. It doesn't have to, but you can do whatever. And then we have a description. This is YAML, which is not the world's easiest, format to understand. So that's where the colors really come in, right? Like, so for example, like if I missed this, you see the colors change. That's wrong, right? It has to look like this, right? So it recognizes it. So the colors, and also if I have an invalid, YAML, like, this would be invalid, then it wouldn't let me save it, right? It's like, hey, I don't know what you're talking about here. So we've got some sanity checking here, it's trying to help us out with colors and also trapping errors when you edit it. You can have comments with, a hash, it makes it green. And but these are main parts of an artifact, right? We have the name, description, the type. Client artifacts run on the client, server runs on the server. We'll talk about that later, but client is usually what you'd want. And then we can have parameters. Okay, we can have names and default values. We'll talk about them a bit later. And then here's where we put the query. So precondition is what will run. So when Velociraptor evaluates the query, it runs this quick precondition query, if it's there, to see whether it should run the query at all, right? And using this, we can limit our artifacts to specific OSs. So for example, here, we can say select OS from info where OS equals Windows. So this will only run on Windows. You can still collect it from Linux machines, but it won't do anything. It's not going to actually run this query at all. It's just because it failed the precondition. So it will tell us that. And doing this makes it safe to write artifacts that you can just deploy widely. You don't have to worry about, oh, is it safe to run this query on this machine? You know, like maybe a query would be specifically for Active Directory or whatever. If you're running it on a domain controller, it would work. If you're running it somewhere else, it wouldn't work, you know, so you can use this precondition to basically just limit, you know, where it's going to run. But anyway, so you can go ahead and click that and, you know, create a new artifact. And you'll see that, scroll up, my artifact that I created appears here. And that little icon here, that tells me it's a user created artifact. So it's a custom artifact. So it didn't come with Velociraptor, right? So you can't change the ones that come with Velociraptor. If you wanted to modify that, you can't actually change them, but you can customize them. So you can click on this pen and you can customize it and save it under a different name. You can choose whatever name you want. You can go like, you know, custom, you don't have to call it .custom, you can go .to, but you can't call it the same thing because you can't overwrite the same built-in, right? But you can call it like .to and it will be like, okay, next to it, right? And that would be your custom version. So you can take the artifacts and change the VQL a little bit and then and this is a good place to start usually when you are learning VQL. So take an existing one and then just change it a bit. And then you have, you know, what you want, right? So yeah, so we've looked at the different parts. This is the search, you know, bar, and this is the artifact repository. All right, and now how do I collect this artifact? So let's start collecting artifacts. So before we saw, where was I? Where's my, here? Yeah. So we could create some custom ones, right? Let's go back to this client. And before we saw, these are all the collected artifacts, right? So we have all the ones that we collected before. So these are the ones that the system automatically generated. But what if I wanted to collect my own one, like just a different one, right? So I can just do that, right? Collect a different one. So I'm going to click this plus icon here, right? And this allows me to create a new collection. So creating a new collection, I've got a big list of different ones, right? And it's all about, and I just create one, right? So I'm going to, for example, for this example, what I'm going to do is get the schedule tasks on the machine, right? Which is a very good, very common way of persistence on Windows, right? So I'm going to look for schedule tasks. So I'm going to search for the word tasks, and I have, you know, a couple of different ones. This is the one I want, right? And it tells me a bit of a, you know, explanation here, so I can decide whether that's what I'm looking for. And this one just parses out all the different task scheduler tasks. Now notice that immediately you can see that I just need to know like what I want, but I don't need to know how to get that anymore, right? I don't really need to remember where the tasks where the tasks exist on the disk because it's already here. And I don't need to figure out how to parse it because the query already does it. So I just need to know, hey, I just want the task scheduler's task. So that's it, right? So just select this guy. And now the next one along is configure parameters. And this is where I can configure this query collection. So I can go in here and I can change some things. And you can see that these are the parameters that were defined for the artifact. And and the UI is building out this kind of, you know, form that I can use to control it. You know, so I can change that part if I wanted to, or I can click this also upload one. And if I check this, then it will, also upload the raw task files as well, right? So as well as parsing them. So it will parse it and also upload it, right? So this is just this particular artifact, how this works. But you can see that using this, we can change the way the artifact, runs. So that's cool. And then I can go and specify resources. And remember how I mentioned before that it's really important that we don't take up too much. We don't have like runaway processes on the endpoint, because people are using these and these machines, and we're going to run like a lot of analysis and forensic IR type work on that. So we need to make sure that we are not interfering with them and controlling the amount of resources that we use on the endpoints to doing this analysis, right? It's really important. So Velociraptor offers a number of different mechanisms to control the way the collection works. So the first one is to get to impose a CPU limit. And so we can tell it, okay, I only want you to use 20% of the CPU resources on the machine. So if you have like, 4 cores, then it will go up to, 20% of 4 cores. So it will be, 50 or yeah, it will use, a certain amount of resources. Hi, are we able to set unlimited max row and max upload? So yes, so you can see that there is a max rows and max upload. You can set unlimited ones, but it's not a great idea, right? Because because Velociraptor is really fast and it will fill up your disk, right? So if you set if you I mean, this is by default, it's like 1 million rows, so you can just like you just go like this. That's sort of unlimited, right? And 1 gigabyte, you can just go like this, right? So you can set it as unlimited, right? Or just set the limit really, really high, but not a great idea, because the whole point here is this is supposed to cover your back, right? In case you have an accident and accidentally you can cause accidents, because we're working at scale here, right? So if we are running if we are running a collection on an endpoint and we don't know what's on the endpoint anywhere, right? So you could say, I just want to grab all the temporary internet files, right? Like, I mean, I had a case like that. I want to grab the temporary internet file from all the users on this machine and get like a kept collection, a kept files connections that we've got a lot of artifacts, grab bulk files like temporary internet files and so on. And that machine happens to be a terminal services machine with like 300 users. I mean, normally your temporary internet files, there might be a few hundred megabytes, but it's not like terrible. But if you have like 500 megabytes and then you have 300 users on this machine, right? Then suddenly you're talking some really, really large amounts of data that you're collecting, because you don't really know what's on this machine. So this is why we have these limits there, to try and stop like an accident from happening. Because if you start to download like huge quantities of data, right, that's going to fill up your server, and it's useless anyway, because what are you going to do with 3 terabytes of terabytes of internet history, right? Like, you can't even process that. It's just too much, right? So this is why these things are set. By default, we have maximum execution time is 600 seconds, so that's 10 minutes. And that is probably the one thing that a lot of people run into often. If we're doing a big Yara scan over a whole disk, it's going to take more than 10 minutes, and it's going to basically time out. So it will run for 10 minutes and then just cancel. That basically is for you saying to Velociraptor, hey, I think this artifact shouldn't take more than 10 minutes. So Velociraptor is going to go, okay, fine. But suddenly it takes more than 10 minutes, then your assumptions are wrong. Something is not right here, right? It stops it from turning into a huge disaster, right? Like where you bring the machine down and users complain that something's been running on their machine for 3 days and using up all the CPU and these kind of things. So that's where it's being conservative is really important. But in this case, we're only collecting the tasks, so it's going to take like, I don't know, less than a second. So we're just going to launch it. And it goes off, and you can see that straight away it comes back, because it doesn't take very long. And because it's connected, it will task it immediately. And so you can see, it took, 3 seconds. And So plenty, plenty of time within the limits, so that's fine. And it completed, so we have check, right? So that's good. And it fetched 200 rows and uploaded 1 megabyte. Okay, that's great, right? So it uploaded the data because we told it to also grab the raw files, the XML files. So that's great. So it's worked on the endpoint. So this is how we collect artifacts remotely, right? And so you can actually go and investigate the endpoint. You're like, okay, so we collected a task scheduler. Okay, so the first thing let me just see where am I up to here. Okay, so we selected that, we chose that, and then we clicked the also upload, and then it fetched all the data. Oh, and then it showed us, yep, it downloaded 200 megabytes, uploaded, this amount of data, right? So it's less than 1 megabyte. It's actually 637 kilobytes, and 200 files. Okay, so this is what it told us that it fetched. Okay, and then we can go through and see, because we told it to upload files. Then if we go to the uploaded files tab here, then we can see all the files that it fetched. So these are task files that that control the way the task scheduler works. So we can, this is the raw data, right? So these are the file sizes. We can look through them, and so you can grab each one. You can grab, like, let's say I want to do this one, so I just grab it, right? And then I can put it through a third-party tool, another tool to parse it, or just look at it. I think these are just XML files. So, just look at it in Notepad or whatever, right? Yeah, open with Notepad. Right, these are just XML files. So I can get the full data if I wanted to, right? But if I wanted to get all the data, I can export this collection. All right, so I'm going to download the results here. So here I'm going to create a download, prepare download, right? If I prepare a download, it's going to generate like a zip file. This is a zip file here that has the data in it, right? So I can export it. So I can click on this guy, and it's going to end up being like a zip file. And inside of this zip file, I've got all the separate clients. So this is this one. These are the artifacts that we collected, task scheduler. And here, this is the ID. And here we have the CSV, of the analysis. We can open that with Notepad, or the JSON. So you have it in two flavors, just CSV or JSON. And then the actual, because in this case we said we wanted to collect specific uploads, the actual XML files. So we can see that it puts it in like a directory structure that mirrors more or less the file system on the the Windows file system, right? So this is going to be more or less where the tasks are, yeah, Windows task scheduler. Yeah, so because we're collecting them from there. So anyway, that's all in a zip file. So we can export the data if we wanted to. Now this little padlock here. So normally when we export it, it doesn't have any password set. So it's just a file, right? If you're in some environments, like if you have a virus scanner or something, and a lot of the time we do download, potentially malware, right, that we fetch. And so, when you do that, the virus scanner is going to like go crazy, right? Because it's going to scan the zip file and it's going to go, oh, you've got some malware in there. So what you can do is you can just password protect it. So that just keeps the virus scanners out. So to set the password, you go over to the admin tile here, to user tile. So the password is like your user preference, right? And then you can create a default password for the downloads, right? So if I just do like password, right? And then when I save it, so now I can decide whether I want to lock or unlock the the download. So if I want to lock it, I'll just prepare it again, and it just makes a zip. But this time, this zip is going to be password protected. But I don't think you can use Windows Explorer with it, because I don't think it supports password. Oh, maybe it does. So yeah, with zip files, you can see the data, right? But you can't read it. So let's just so this is the locked one, but I can't actually extract it. I don't think Windows Explorer does password zip, so you need to use 7-zip anyway. Yeah, so this is just so this just stops the virus scanners from getting this. All right, so I forgot about the break. So wait a sec, what is the time now? So it is 12:18. We started at 11, and we're going to go until 1. Do you guys want to just keep going, or have a small break, or we'll just go till 1, or maybe we can finish a bit earlier? I don't know. Keep going? All right, cool. All right, so great. So we looked at the upload tab. That's great. You can grab each file individually or just export it. We covered that. So the next thing is the query logs. So when a query runs, you need to know like what's going on with this query. What is it doing? So as the query runs, we generate these what we call query logs. So the query logs things as it goes along, right? And this is important to know, like, what is the query doing, and if it's running into errors as it goes along, right? Because it's not, you gotta remember, VQL is not an SQL. It's not like a database, right? So when we are running a VQL query, we are actually going to look at files. We're opening different files. We're trying to parse. So we're doing all these things, and something could go wrong. We could have access denied. We could have problems, right? So we need to know what's happening to the query as it happens. And this is why we are generating query logs. So the query logs is just a way of just getting a visual of what's happening. And so you can see that the query starts off and it's telling me, yep, I'm starting. Great. So, and then a little while later, it tells me, okay, I'm going to send you some rows. Now, if the query runs for a long time, so Velociraptor also is not, it doesn't get all the rows and then send them. It sends the rows as it finds them. So imagine if I did a Yara scan or something, a search for the file system for keywords, and it's going to take me maybe 10-20 minutes to do, right? But let's say I found the keyword in the first directory, and then it's going to keep working, right? But I want to know about this result as soon as it happens. So it streams the result as soon as that happens. So it may actually send me rows, partial rows, all the way through, right? All at periods of time, like during execution, right? So it just sends rows along. And so this message is telling me, okay, I sent this, and then it's going to say, yep, I uploaded 200 bytes. That's great. And then it's saying, okay, I did it. It took me 2.9 seconds, and then it gives me some stats there. So I got like, how many rows are scanned, and, functions called. This is just VQL stats. So this is called, this is basically a log of the query. So it's good to look at and see what is happening as the query goes along. And then we have the results tab, and that shows me actually the results, the table, the rows and columns that are returned, right? So these are the results. So in this case, because we're doing the task scheduler, we are parsing those XML files, and we're extracting certain things from it that are relevant for this usually relevant. That's what the artifact is doing. So you don't have to parse it and look for the data. It just puts it right there for you, so it's easy to understand. So for example, here in this task scheduler, what we really care about is what is starting. What looks odd. For example, like there's a service, there's an SC command being run. So the commands that are running as part of the task scheduler, and their arguments. So it's important. Like this could be suspicious, right? It's starting a service, right? These kind of things. So we can immediately see anything that stands out here, right? Okay, and then we can go off and look and see whether they're legitimate or not, whatever, right? Okay, so where was I? Yeah, so files. Sorry. Yeah, so log messages, look for errors. So in here, right, it's telling me how many files it uploaded. Yep. And then some artifacts that return multiple tables, multiple queries. Remember that sources selected that I showed you before. Some artifacts can return multiple tables because they have multiple queries. So what we do is inside of the same collection, we put them as separate tables in the UI. So in this case, we only have one, but let's get the users. This artifact that Windows Sys uses. So that one collects information about the users on the system. And it actually has, oh no, maybe it only has one. Oh, maybe, oh yeah, sorry. This is when we collect multiple things at the same time. So you can actually collect multiple things at the same time. So you can collect users. So this is what we did before, but you can also search for prefetch, for example. Okay. And so when we configure the parameters, we're actually collecting two artifacts at the same time. So in the same collection, we have two things. You can have lots of things in the same collection, right? And then when we collect it, so we're just going to collect them, then they're going to end up looking like this, right? It's going to say, I've collected two things. So we have 1, 2, right? But, you know, we've got, this is the ones that came back with results. And then we've got different tables here. So this is the first one. This is the second one. So we can see the outputs are separated out. All right. Let's take a look. Okay. Then we talked about export. So we actually talked about that already. We can export it, prepare the downloads. Yeah. So really, just to summarize this section, the important thing about VQL is that it's a glue language that we can put together all these analysis modules and create additional value by combining them in novel ways, in different ways. So, for example, when we looked at the task scheduler, I just wanted to quickly show you. If you look at the task scheduler, what we're doing is we are using an XML parser, right? So we can parse an XML file. We're doing some regular expressions. We're doing some globbing. So globbing are searching for files. And you can see that these are basic building blocks. We're searching for files, then we find the files that we want to do, then we read them, right? Then we do some regex on it. And then we take that data and then we parse the XML and then we extract the fields that we want out of it, right? We just want to get out what we want. So the idea is that these basic building blocks, parse XML, glob, they are the ones that are available in VQL, right? To do the heavy lifting. But VQL just puts them together and suddenly we have a better analysis, right? So, I mean, we could have always written a script or something to parse out the XML files, but then we'd have to build it in and push it and that. So we can just do it all inside the VQL. And that's really the power of VQL. That's the whole point. We have some very sophisticated analysis modules there, but we can use that. All right. So, yeah, we've got lots of different, oh, there's a question, really quick. Can we request the agent to collect artifacts from more than 1,000 installed machines? And what will the server-side performance? Yes, brilliant. So this is exactly what we're going to do next, next exercise, right? So 1,000 is not very large, actually. So as we mentioned before, we normally run at about 10 to 15,000 endpoints. And so we can collect the same artifact from all of these endpoints at the same time. And that's called a hunt. when we hunt for it. So we're going to cover that next. That's a good question. All right. So the whole point is that we can share these artifacts. So we can share the VQL with other people, and we have a community. And this is our Velociraptor Artifact Exchange, which is the place for people to share their artifacts. So it's on our site here, and you can search for an artifact what you want. So you see there's a whole bunch of different ones. We can pick random ones. Like this one, Parges Little Snitch network traffic. This one looks at the macOS FS events, so on. You can click on any of those, and then you can see how it's the same kind of structure. This particular one, just in random, but this one uses the binary parser to parse these FS events logs on on macOS. But anyway, you don't care, right? You just want to use that. That's great. This is the globs. You just import it. You're done, right? It works. And so you don't have to worry about it too much. So the artifact exchange is where people contribute artifacts for all kinds of purposes. So there's quite a lot. You can click share your own artifact here, and it tells you click contribute. It goes to GitHub. You can contribute your own artifact. And we collect these things here. So there's a few hundreds here. But so here's the screenshot of that. But what we really want to do is, if you just want to import the entire exchange if you remember here, we have, these are all our Velociraptor, these are built-ins, and these are customs, right? These are all the Velociraptor artifacts. But if you want to just take the whole artifact exchange and load it in one step, so you don't have to worry about it, you can do that. So you can go and do this thing called server artifacts. Server artifacts are just VQL, but instead of running it on a client, as we've seen before for the task scheduler, we're going to run the VQL on the server. So you can actually collect those on the server. And so there are actually quite a few server artifacts that are designed to work on the server, because the server itself can run VQL too, right? And you can use that to do administration type tasks by controlling the server with VQL. So in this case, what we want to do is just search for import, server import artifact exchange. And you want to take, this basically goes out to the artifact exchange on GitHub and grabs the latest version, and imports it. So super easy, right? So all we have to do, click launch, and it's done, right? It basically goes and downloads it and imports it into this server. Now, you can also maintain your own, all it is, the artifact exchange, just a GitHub, right? With YAML files, right? So you can do your own content, manage it on your own GitHub, and then use the same artifact to sync that to your own server as well. So you don't have to work with just our exchange, right? There's nothing special about our exchange, just a place people contribute, right? So you can see that what this did is it's gone through and it's actually imported all of these, artifacts. And again, it's got rows and columns. But now if we go to our, this one, the view artifacts screen, so we can see a lot more of those custom ones, right? And it puts an exchange prefix to it to let you know that came from the exchange, from the artifact exchange. So that one that we've seen before now becomes part of the, FS events I think I showed. So actually, since then, it already got incorporated into the tool as well. But you see that artifact from the exchange may be different, or I don't know, but it shows up separately, right? And what was the other one we looked at for an example? Binary Hunter, some covers and so on, CVE ones, there's lots of them. But they're all now available in the same server because we've imported them. So it's really easy to just import all the artifacts from the exchange and into the server, right? All right, so let's see. Okay, so we've got like 30 minutes, so that's cool. We could make a start on this one. Cool. All right, so we've learned about Velociraptor. We've looked through the UI a little bit. Now let's look for files. Searching for files. So that's the first type of things that we do in forensics, right? We're always concerned with searching for files. So sometimes we search for files because we want to find a file name. File name is special, like it's some kind of malware.exe or whatever. Sometimes, we search based on content. The file may have some extension, so the extension may be interesting, or the location of where it is interesting. Sometimes we might find the content would be interesting, and sometimes we want to search for a signature in the file that will indicate it's a particularly malicious file or interesting file or whatever, right? So searching for files is like, I don't know, maybe 60-80% of DFIR. I don't know. It's quite popular. So let's look at how we normally do file searching. And because file searching is used for so many different things, it's quite a wide, open-ended kind of artifact that gives us a lot of power to customize the different things that we can do with searching. So the one that we normally use is the Windows Search File Finder. And let's look at it here. So we go back to our artifact collection, and let's look for File Finder. So search for Finder, and we have one for each OS. This is a Windows one, so we're going to use the Windows one. And you can see that it has, the VQL has a lot of filters and customizations and these kind of things basically. And so it comes up with so you can see that these are the parameters that it defines, and in the YAML, and so that creates this configuration screen, right? So we've got these different kinds of things that we can influence it. So we start off with a search file globe, so we can find a search, start searching in a particular place, right? Now a globe, if you don't know, is a way of specifying a path with wildcards. So usually you use star or question mark, right, for the wildcards. It's not really a regular expression, although it gets converted to a regular expression, but it's not. It's supposed to be like much easier to use than a regular expression, right? So it just has stars and question marks, but that's it basically. So it's not really as expressive in terms of filtering, but it's very easy to use. Everybody understands star.exe, So the only difference that you can do in Velociraptor is that you can use something called a star, which just means recursively search down directories, whereas just a normal star is just in the same directory. And for example, like if we want to find all the executables, we would do star.exe. Now over here, if we wanted to have more than one, like lots of them, different ones, then we can just add it into this table. So we can just go plus, add more things. It doesn't really matter. You can add more or less. Doesn't really matter. So you can keep it or not. Now notice that you can use / or \. It doesn't really matter. Velociraptor doesn't mind which you use. On Windows, it / is probably looks a bit better. I don't know. Then we can search for the auto. So we can search the registry as well, which a lot of people don't immediately realize. But you can use this artifact to also search the registry using these accesses. We'll talk about that in a minute. But or you can also have a Yara search for looking for the content. So if you don't know, Yara is sort of like the standard way of specifying a matching rule based on content. So it's like a very powerful grep, I guess. It searches for patterns in file, and it has a domain-specific language that specifies how to search for files. So it's like a special Yara rule format. You can Google for it and so on. It's not that complicated, but it's kind of verbose for simple things, but it's good for if you have a very complicated matching rule. So you can also paste a Yara rule in here, but normally, because Yara rules, are hard to write because it's just a lot of, verbose, very verbose. So we have a Yara like editor here, so it helps us to write Yara rules. So if you just press the question mark, and it tells you that's question mark for suggestions. So press the question mark, and you can insert a rule template, and that helps a lot, right? So that is basically what a rule looks like. So because you see it's a bit verbose, but once you get the template, it's pretty straightforward. You're like, oh yeah, that's my keyword. Any of them, all of them, 5 of them, and then you can sort of, most of the time, if you're just looking for a keyword, that's actually you just change your keyword here. And then, for example, like Velociraptor. We're going to search for executables that have the word Velociraptor in them in the user's home directory, right? So this is basically what a Yara rule looks like. It's very easy. Like no case just means case insensitive. Wide means UTF-16. And ASCII means ASCII, right? So these are the different possibilities, different versions of this string that we're going to search for. And then once we find the file, we can upload it or just maybe calculate the hash of it, let's say. And here we can restrict by, dates. So we can say it has to be more recent than, and then let's go to, anyway, August 10th, let's say. So that restricts by time. So you can have all of these or any of them or whatever, right? So these are conditions that we can put on the file finder, and then we can review it. This just shows us the query that will go out to the endpoint, so we can see the conditions that are added. There's not much to see here, so it's not that exciting. But then once you launch it, then off it goes looking for that file, right? So what it's doing is, again, it's running that query on the endpoint, and it's using those plugins, the Globe, the Yara, all the different ones, to essentially search for files on the endpoint. So we can click on the log, all right, and we've got 13 rows back from that. It took 14 seconds. That's great. Let's look at the results. Okay, and we can see we're looking for, remember that we're looking for anything in the C users star.exe that had the word Velociraptor in it, right? So because we're looking for a Yara SIG. So we found one hit here, and of course, the Velociraptor binary that we just downloaded. That's great. And it had several hits here. So we're actually showing several hits in here. And then here we've got the hash of this thing. And so like, let's say we are like, oh, there's a hash, because we told it to calculate the hash, right? So we're like, okay. And then if we can right click and we're like, oh, I wonder if this hash is any good. So let's varus total it, right? So we're going to hit that varus total, and it's going to go, yep, here's the hash, it's Velociraptor. It knows because someone had submitted it, and it has the details and whatnot here, our community, whatever. So we've got a quick way to spot check. This right click menu is like a quick way to spot check specific things. You can also go to Cyberchef or just copy it to the clipboard, whatever you want. But yeah, so this is how the file finder works. Basically, it's very open-ended. So you have to kind of like be creative about what you're looking for and try and think of it in terms of what to search for. As a question. May I check why are there repeated entries? Because there are multiple hits in the same file. So in this case, it looks like it should have probably limited it to one hit here, but there are multiple hits. So it shows you one for each hit. And the string.data. So it shows you the data of the hit, but because So our regular expression was just Velociraptor, right? So it's the same every time. That's the hit. But I would say that yeah, this data. So it should show us the hit in here, but I would say that it probably needs to only show us once. Yeah. So if I don't know if it's a bug or not, but anyway, we can change that later. Again, if you want to customize one of those, super easy. You just basically go over here, File Finder. Okay, and I want to customize it, and I wanted to show, like, that's a great question. So let's say at the moment it's showing 1 hit per hit, right? But I actually wanted to, so this is the Yara, but I just want to say, just show me one hit, right? Number 1. So that should show just a single hit. So now it's going to be custom Windows File Finder, right? And I can then go and customize it and collect that one instead. Right, so this is my custom version, and start.exe, and then Velociraptor, calculate the hash. Right, so that should hopefully make just show 1 hit. Another question. Is a tool like Cape? Well, okay, so the question is, I think Velociraptor is like Cape, but we can fine-tune it to collect artifacts in real time. What I'm thinking, if Velociraptor VQL can be triggered when an EDR alert of severity read for collection of relevant artifacts. I love it very much. For compromise assessment. Yeah, so it's mostly used for compromised assessment. And Cape is really a file collector. So it's a little bit different, right? And I don't know if we don't really use Cape file. So we also can collect files as well. So there is this, I don't know if I'm covering it today, but there is this Cape files target artifact, which comes from the Cape file repository that contains all the location for all these things. So we can do that, and that collects files in the same way, right? So if we collect that one, for instance, then this is the same thing as what the Cape tool does. So we can click basic collection, and it's gonna go and collect all of these targets, or but like the basic collection would be the first one, right? And so if we do that, and then we can go off and do it, right? And it's going to take a while and just collect. You see, it's just starting to collect, a bunch of stuff and starting to upload a lot of data, right? And the whole point so this is what Cape is collecting lots and lots of data, right? And Velociraptor approach is really different. The point is, it's not about collecting data, it's about analyzing the data and getting the answers that you want from it, right? So you see, if I was to collect this basic collection on 10,000, I can't, right? Like, it's going to pull down about 600 megs, maybe a gig, in some cases 2 gigs, 3 gigs, right? If I have, 10,000 machines, I can't do that. And what am I going to do with this data anyway? Because I can't really process it, right? So the philosophy of Cape and Velociraptor are very different. Cape is really about collecting lots and lots of data. It's kind of useful for preservation if you need it, but we don't really use it that much. But I know a lot of people use that because that's kind of the the state of the art of like how it was. That's the old school way of doing it, right? So I know a lot of people use it and collect lots and lots of data, right? But so that's really the main difference. In your question, you say it's Velociraptor is like Cape, but it's not really like Cape. It's very different because Cape is really all about collecting lots of data, And Velociraptor is really all about parsing that data. So for instance, like in this case, we collected this. And if you look at the upload file, so that like, so, okay, so we grab the MFT. Great. So now I've got to do this MFT. What am I going to do with it, right? I have to like download it and then run like parse mft.py or some other tool on it. And it's just annoying, right? Whereas I can just go and say, parse the MFT, right? Boom, right? And I just do it straight on the endpoint, timeline it or whatever, right? Like straight on the endpoint. And I don't need to fetch it first. I just get what I need straight from it. So that's the idea. Well, we're going to look through that. So, but think about that as we continue, you know, and and think about that approach, the difference in approach. Another question, I understand that some of the artifact functions require internet connection so the program can run. How can it run offline? Well, that's a great, that's a good question. So, so we have this thing called offline collector, which actually I didn't cover it in this workshop, but a lot of people need to, they can't really install an agent on the endpoint, right? They want to collect these data, but they can't install the an agent on the endpoint. So we have this thing called offline collection mode, which is the same as, it's the same thing except that we're collecting it to a local file rather than sending to the server. So how you do it is you go over to the server artifacts section here, and then you click that little paper plane, I guess, build offline collector. So we click on that, and then it looks the same as collecting an artifact, right? So we could you do the same thing. Let's just, and typically we would collect, you know, the cape targets here, but you can also do other things like task, you know, the thing that I did before, the task scheduler, you know, and prefetch, for example, yeah, forensics prefetch, whatever. And then it's the same thing. We configure the parameters. Here we'll do like basic collections. Actually, let's do something smaller so it doesn't take as long. Let's do just the MFT. All right. And then the task scheduler, we can also upload those, you know, like these things, right? Prefetch, whatever. And then what we're going to do is configure the collection. And here we're basically going to build an offline collector. So an offline collector is just a binary that's pre-configured to do that thing that I told it to do, right? So we're going to build it using the Windows binary because we're going to run on Windows. You can do things like, you know, send it to a cloud or whatever, AWS, whatever, but we're just going to do it locally here. And you can also specify the resources and things for that. But anyway, when we click launch, so what that will do now is it will fetch the Velociraptor binaries into this server, and then it can use that to repackage them with the correct configuration. So this is called offline collector. So you can see the documentation for that on the website. But what happens is that using that, we end up with a binary. I'll just, it takes my internet is not the fastest, so it takes a little while to download it. But once it's happening, then I'll show you how that works. But then you don't need to have Velociraptor like connected. I don't know why I didn't include it in this workshop, but I don't usually use it that much, so I didn't include it, but I know a lot of people do use it. All right, so we talked about the file finder. So file finder is really, really critical, really important. Final executable uses home directory, we've done that. And the whole point is to collect and parse. So collecting the files, this is what I showed you with the cape files. It's just about collecting large number of files. So let's let that keep going. But then what do you do with these files, right? We saw that we got these files, we've got the MFT. What do you do with it? At the end of the day, I don't care about the MFT file. I care about the information in the MFT file, right? I want to know about specific thing, about specific investigative question. So collecting the files is like the first step, but I don't really care about that. What if I don't collect the files? What if I just answer the question straight away? Then it's much faster for me, right? So this next example, I'm going to show you how we're going to do collection and parsing on the endpoint at once. So we don't need to collect it separately. So this example is running this thing called SQL eCMD, which is another one of those Eric Zimmerman tools so Eric Zimmerman has a tool called SQL eCMD, right? But it turns out that this tool uses, again, a whole bunch of, I think it's YAML files, but prepackaged these queries. And so we can convert those queries to VQL. So we don't need to run a special tool. We just use the same data to do the same thing in VQL. Let me just quickly show you that. Right. So what we could do is SQLe. We can just collect. So there is an artifact called SQL eCMD, which is consists of essentially the same data that the tool SQL eCMD uses. See, they're just a big list of globs and queries and so on. But the idea behind that is really cool. The idea is to make it as automated as possible, so it just knows what to do. So we don't have to do anything. We just select this thing, and then we just click launch, and off it goes. It does this thing. So it basically, this tool has a whole bunch of places to look and things to parse to try and detect where we can find SQLite files that are useful for analysis. So SQLite files are used in lots of places, including browser artifacts and these kind of things. And so this thing goes off, grabs all the SQLite files, then it queries the SQLite to pull the data out, right? And so we don't really need to collect the SQLite files and then find them and so on. We just immediately parse them on directly, and so we can get the data straight away, right? So this thing is going to run off, and you can see that it found a bunch of SQLite files used by Chrome and so on, and then it's starting to parse them, right? So this is all the cookies that come out of one of them, and the downloads. These are the different things, right? So it's in total uploaded 2,500 rows, but they're in separate tables. And so this is a really great example, one of those artifacts that's really easy to use, and it actually works really well. And you don't really need to know much about it. You just click this thing and off we go. All this data comes back. It's great. So so let me just show you. So this is kind of, to me, that represents the difference between collection and parsing. Now, in the case of, I just wanted to quickly show you, in the case of this, if you look at the log file, there's quite a few ones that will be locked. And so Velociraptor knows how to kind of handle those locked files. So it's, it's a little bit more robust. As far as the VQL is concerned, we don't need to worry about it, but Velociraptor will copy them over and unlock them and then find, and then be able to parse them. So the idea is that Velociraptor itself is able to handle all of these data. These are, and you can see that in the log. Okay, so before we do that, let me just quickly go back to the thing that I showed you before with the offline collector, because I know a lot of people use it, and I probably should have included it here. But when we build the offline collector, then it creates a binary. So we are in the server artifacts, right? After we click the little paper plane, and we come back, and it's built this this binary, right? So it's uploaded it to the server, and this is the pre-packaged binary. So if I download it, it's going to basically download it to the server. And what I'm going to do is start another command prompt, right? Okay, so this is the one that built the collector that it built. So this is the offline collector. So all I have to do now is just run it. It already knows what to do, right? So it's been pre-configured in the GUI, right? So if I run it, then it goes off, and you see that it's already knows what it's doing. So remember, I told it collect the MFT, right? And then do the prefetch and do the schedule tasks, right? So it's going to go off and do that thing. This is useful for when you have like you don't have access to the machine, right? But you have to collect data from it. So you might have, you know, someone on a help desk or whatever, and you might say, hey, run this thing, and the zip file that it makes, you know, send it back to me or whatever. Or you can actually even get that to you know, to upload automatically to the cloud or whatever. So then they don't have to fumble around with, you know, command lines and try and find these, you know, these things. So it creates a zip file here, and that zip file contains the things that we've collected. So, you know, the MFD and all these things. So this is going back to that question about offline collection. So you don't have to install anything here. You just run it, collect it, and in that way, it's a little bit more similar to Cape, because Cape is really all about collecting files. But the main difference here is that we are also doing the parsing, right? So we're not just collecting the files; we're also doing everything on the endpoint itself, right? The parsing and everything, right? So, so if I, you know, look at it, here's the collection zip file. So it's just a zip file. I can open it up, and you see that here is the prefetch JSON. So this is actually the result of this one, the result of analyzing it, right? So now I can actually import that back into Velociraptor and use the interface to, you know, to query it and so on. So I don't have, I guess the takeaway from here is I don't have to have Velociraptor installed. All right, so I think this is now lunchtime, right? So we've got a lunch break now for 1 hour, and then we're back at 2 p.m. So if you guys have any questions at all during this lunch hour, let me know, and just write them in the chat, and we can chat at any time, whatever. We'll be back in an hour. Timing worked out, actually. Cool.